K-means made us commit to a number of clusters before we even started. Hierarchical clustering takes a completely different path. Instead of picking K up front, it builds a whole family tree of the data, and we choose how many clusters to keep afterwards. It begins in the humblest possible way. Every single point starts as its own tiny cluster. 6 points here means 6 clusters, each a group of 1. Below, we'll grow a tree that records everything that happens next. The rule is simple. Find the 2 closest clusters, and merge them into one. These 2 points are nearest, so they join first. In the tree below, we draw a link connecting them, and the height of that link records how far apart they were when they merged. Then we just repeat. Find the next 2 closest clusters, which might be 2 points, or a point in a group, or 2 groups, and merge them. Again and again, the little clusters fuse into bigger ones, and the tree climbs higher with every merge. Eventually everything joins into one cluster at the top, and the tree is complete. This tree has a name, a dendrogram. Read it like this. The higher 2 branches join, the more different those groups were. Short, low links mean very similar points. Tall links mean we bridged a big gap. Here is the payoff. To get clusters, we simply slice the tree with a horizontal cut. Cut up here, and we cross 2 branches, giving 2 clusters. Slide the cut lower, cross 3 branches, and we get 3. We decide the number of clusters after seeing the whole structure, no guessing beforehand. One detail we glossed over. What does distance between 2 clusters even mean? That choice is called the linkage. Single linkage uses the closest pair of points. Complete linkage uses the farthest pair. Average linkage uses the average over all pairs. Each gives differently shaped clusters, so the choice matters. So how does this compare to K-means? 2 big advantages. You don't fix K in advance, and the result is deterministic, no random starts to worry about. The dendrogram itself is a rich picture of the data. The catch is speed. Comparing every pair of clusters is expensive, so plain hierarchical clustering struggles on very large datasets. In scikit-learn, agglomerative clustering does the merging. You tell it how many clusters to keep, which is the same as choosing where to cut. And to actually draw the dendrogram, we reach for scipy's linkage and dendrogram functions. To recap, hierarchical clustering starts with every point alone and repeatedly merges the 2 closest clusters, building a tree called a dendrogram. Cutting the tree at a height gives you clusters, chosen after the fact. The linkage sets how cluster distance is measured, and the main cost is speed on big data. Next, we switch gears to dimensionality reduction.